Low, low, low. Wow. Um, it's incredible how this video can be so mundane, but also very personal and very intense. Um, so far, I see some new faces. So if you have not been here in the morning, we introduced the day with a small meditation to check in with the space, with ourselves, with each other. Then we talked about race and technology with Dr. Ramon Amaro. And then we talked a little bit about embodiment, the nature of the human voice, whether it's synthesized or embodied, and how we can work with our body to understand identity and tech. But now we're going to talk cosmic, we're going to talk quantum. So this next bit is really about exploring quantum bodies and space knowledge. And the question that we want to pose in this next bit is that, is it really possible that we exist in multiple forms in different worlds? What does outer space teach us about bodies and behavior? There are physics theories that leave room for this thinking at a quantum level. These bodies are at the same time in different worlds and states. While there's no proof yet of the existence of multiple realities, we can learn a lot about our potential alien relationships with outer space at the quantum level. It challenges one to review the Western-based frameworks of biological identity, moving towards new, fluid, queer cultures of the 21st century. In this session, we look at how artists and researchers work with scientific research and imagine possible realities. So we're first joined by Libby Heaney, who will be joining from the UK remotely. And she's widely known as the first artist to work with quantum computing as a functioning artistic medium. Really exciting, I know. Her practice explores inherently queer non-local hybrid concepts from quantum science to disrupt binary categories and hierarchies and foster radical interconnectedness. So she's an award-winning visual artist with research background in quantum information science, obtained a PhD from the University of Leeds. As a scientist, she has worked at the University of Oxford and the National University of Singapore, and she has published in top peer-reviewed journals. She was a recipient of the HSBC and Institute of Physics Very Early Career Woman in Physics Award. 2015, she graduated from the Central St. Martin's in London with a focus on AI and kinetic sculpture. Since then, she has exhibited in major institutions, museums, and festivals such as Art Electronica, Tate Modern, V&A Museum, HEK Basel, Sonar Festival, and Last Art Foundation. So without further ado, please welcome her on the stage.
Hi, thank you so much, Abdul, for the kind introduction. It's really great to be here remotely at Fiberfest today. I guess you've heard a little bit about my background, but I'll start by talking a little bit more about it. So I worked as a quantum physicist for around 8 years before I made a transition over into the arts. Quantum physics is a theory of reality that is really different to how we experience the world around us. So we live in a macroscopic world. We see objects in this world as kind of boundaried and fixed. And whereas a quantum world, which is at the microscopic level, is very different to this. So in my research background, I worked with a phenomenon mostly called quantum entanglement, which I'll get to shortly. But when you work in an academic discipline and you're working on a topic that's so esoteric that at some point you can't even talk to your colleagues about it. I wanted to explore the magic of quantum more widely, so I went back to art school to my first passion, and now I combine the two. So I work across different medium in my art practice, from quantum computing, games engines, artificial intelligence, but I weave these with more traditional medium. So watercolor painting, glass sculpture, installation, soft sculpture, all sorts of things. And the idea is not to kind of make work to illustrate the science. I'm not doing scientific outreach, as you're probably all aware, but rather I'm looking at quantum technologies critically, but then also looking at the radical potential of quantum physics and the differences that it has with Newtonian physics to reimagine bodies, but also the systems that we live within every day. How can we move from this sort of seemingly fixed reality, capitalist, patriarchal reality into something that is fluid, non-local, non-binary? And what does this mean? And how does this manifest through a visual art practice? And, how can we talk about these phenomena in a way that's accessible? Because quantum physics can be quite challenging to people at first before they get used to kind of the ideas behind it. But then once you do, you can find that this is quite magical. Um, so, so how is quantum physics different to the Newtonian world? There's two main phenomena that I'd like to focus on. The first one is quantum superposition. Now, quantum superposition is where you take one entity. So this, in the quantum world, we're speaking about the macroscopic world. So this is atoms, molecules, photons, which are particles of light, anything that's really small. And generally, it has to be cooled down to temperatures colder than deep outer space. So perhaps minus 273 degrees. And then you start to see things like quantum superposition. So quantum superposition is where one entity, one atom, is in multiple contradictory states at the same time. So for instance, this atom could be spinning down and up at once. We don't see, say, footballs or people falling down and up at the same time. Usually we're doing just one thing, not both, in this macroscopic world. The other phenomena that's really important within my practice, but understanding quantum physics as a whole, is this phenomena of quantum entanglement. So quantum entanglement is superposition generalized to two or more particles. So if you have two particles that are entangled, they are, are joined together in such a strong symbiosis that the notion of the individual disappears. They're so attached to each other that you can no longer retrieve an individual out of it. If you try to, you destroy the system. And quantum entanglement, the fascinating thing is it can happen even if these two particles or these two bodies are really far apart. Scientists have done experiments on entangled particles from Earth into space and shown that these are still deeply interconnected, even though they're non-local. So this is the idea of non-locality. Rather than having a causal connection between them, their connectivity becomes acausal. There's no longer a transmitting medium. No, there's no longer this sort of Newtonian time between them anymore as well. So quantum entanglement and quantum superposition are just two of the key features that sets quantum physics apart from Newtonian world of cause and effect. There's other features as well, but obviously I can't speak about the whole of quantum physics today. So quantum technologies, so what you're seeing in the background at the moment is one of my video works. You're going to see throughout this talk, you'll see a different set of video works. I think where they've put me on the screen actually covers the titles up, but you can look, if you want to know what they're called, you can look on my website afterwards, or maybe they can move me across to the other side of the screen. But the important thing is that scientists are currently trying to use quantum physics to build a new generation. Thank you. A new generation of really powerful computers. So if you think of current digital technologies, any digital computer, whether it's your phone or the world's biggest supercomputers, are binary. They work on a system of zeros and ones, but they do the calculations step by step, sequentially. The state of the computer is only in one configuration at any time. It's like thinking about a bit can either be yes or no. zero or one. It's never both at once. But when you go to quantum technologies, because of superposition, where you can have one thing in multiple states at the same time, instead of bits, you move to qubits. And qubits are non-binary, so you can have zero and one at the same time. And this leads to much greater possibilities within the quantum computer. Rather than calculating anything step by step sequentially, quantum computers run in parallel. All possible calculations take place at once, which gives them exponential power for certain problems compared to digital computers. Now, what does this mean? So in the future, full-scale quantum computers do not exist yet. There's a big sort of, I guess you could call it an arms race. Who can build the world's first quantum computer? Google, IBM, Microsoft, Amazon, and a plethora of startups across the world, in the East and in the West, not so much the global South, sadly, are racing to build the world's first full-scale quantum computer, because the world's first full-scale quantum computer will be able to decrypt all the currently used encryption, including the blockchains. There are methods to make these secure again, but they're not widely taken up at all at the moment. Future quantum computers will be able to search unsorted databases, which is also currently impossible and always will be impossible on digital computers. Things like the traveling salesman problem, so optimization problems. If you have to deliver parcels to thousands of locations, what is the most efficient route? And this is impossible as well. Also, quantum computers will be able to mimic any systems that are based on atoms and molecules, because these systems need quantum computing to solve them at a really in deep at a level that's really in depth. So current digital computers cannot model atomic and molecular systems really precisely. It's impossible because you need to have a quantum computer to do that. And that will lead to new drug design, new ways of mimicking biology. People have said recently, I was speaking to a scientist in Oxford who said that this will lead to a greater understanding of the human brain, and therefore we would need quantum computing to lead to artificial general intelligence as well. So, how long until quantum computers are fully developed? Depends on who you ask. If you ask big tech, they say the next 5 years. Obviously, they're trying to sell their very noisy, sort of like current quantum computers that don't really do that much at the moment, to be fair. I know because I've tried to use them. And then also, I would say about 20 years until a full-scale quantum computer exists. But when they do, they will change the world in ways that we cannot currently imagine. You know how when the internet was first developed, we couldn't imagine that we would be carrying around smartphones in our pockets and AI would be making reels for TikTok. We can't currently imagine what quantum computers will do. But based on the sort of history around big tech, we know they will probably be used currently to advance modes of surveillance capitalism, to extract more data about us. There are quantum machine learning algorithms as well. In the background at the moment, you can see my video Q is for climate. It's a really interesting question how quantum computers intersect with climate change, or future quantum technologies will intersect with climate change. Big tech often say, oh, we will use quantum computers to help solve the energy crisis. So they will be used to help develop a whole new generation of lithium-ion batteries. Or we'll understand photosynthesis at the molecular level, so therefore we can do biomimicry. And that sounds great. But then when you actually investigate on the websites of the companies that are using quantum computing or developing quantum computing, one of them, I'm not going to name names at the moment because I'm in a public talk, but you can do the research yourself or DM me on Instagram. But if you go on one of the big multinational companies trying to develop quantum computing, they say they're going to use it expedite oil drilling and exploration. Hence, you see oil in the background of this work at the moment. Another big tech company has partnered with ExxonMobil to think about gas shipping around the globe. So there's this, and even with big tech companies there's certain startups that want to work on solving climate change, and they've pledged that when quantum computers are fully developed, they will use some of that limited capacity to work on problems that will help us solve the energy crisis. Yet they're still working in this regime of linear extraction. So what this video does shortly is I start using quantum computing to edit the footage together. So you'll see at the moment, the footage is kind of edited together in a traditional way, step by step, in a linear way. So one clip is present on the screen, and then the next clip, and then the next clip. But what happens when I use quantum computing to edit video, as you will see shortly, is that I'm using when I work with quantum computing in my practice, I'm not using it in a binary way like the scientists are using it. The scientists want to solve binary problems. They want to solve problems where there's an answer, a true or false answer, or they're modeling reality. They're trying to copy the existing reality, but they can do that in an exponentially faster way. I'm not interested in that. What I'm really interested in is the queer, non-local, non-binary properties of quantum entanglement and superposition, and how that can help us see the world or understand the world differently. So with my quantum video editing technique, I'm using one of IBM's 5-qubit quantum computers. These used to be publicly available online, but as with all hardware, things get upgraded and changed. So they're no longer available via the cloud. There's different computers available now. But I encourage you all to go and have a look on IBM, because there are some publicly available quantum computers that you can use and start to experiment with in your own practice using Python code and their library Qiskit. So I'm using 5 qubits, and when you entangle 5 qubits together, you can generate a giant superposition with 32 different layers in it. And I use this superposition from this type of entanglement and the correlations within that to layer up 32 different videos, all playing at the same time, and their transparencies and opacities depend on the data from the quantum computer. So how I extract the entangled correlations from the 5 qubit entangled state. It sounds complicated because it is. I'm not going to get into the details here. It would take, yeah, it's beyond the scope of this talk. But what you start to see is a more nuanced view of how we could work, think about systems generally, where rather than having linear time and optimizing for one point of view at any instance, you have all points of view interacting, to use a term from Karen Barad, all at once. And I think this gives us, like, rather than having one sort of narrative, we're thinking about all possible narratives and all possible times in kind of this multiverse that Abdul mentioned in the introduction. Because when you're working with quantum computing, what you're really creating inside the quantum computer before you collapse the system is a layered reality where all possible layers exist at the same time. Um, Perhaps you've seen the film Everything Everywhere All at Once, where there's all of these different layers of narrative and the film is cutting between them. What I'm doing in my work is really superposing them all at once. So this is now you can see the quantum video editing. So there's 32 different videos all playing at once here. And different points of view, different visions come to the top or bottom, depending on the data from the quantum computer. And time here is non-linear. There's no forward progression. There's no directionality. Time loops around and is non-linear. I think that's very important as well. The aesthetic is blurred and layered. If you think about the idea of seeing double, we see double, if you have had concussion or if you're inebriated somehow, maybe we see reality as double. And then it's layered and blurred, isn't it? Maybe you see two versions of what's in front of you, one for each eye. In the quantum world, it's not our perception of reality that's doubling, it's actually the physical reality that is layering over itself inside the quantum computer or in a quantum physics experiment. And this is what you start to see in the quantum aesthetic, this layering and blurring. So it's a new way of looking. I feel that as quantum computing develops further, we'll start to see more and more different ways of looking that come from the quantum world. We can never fully represent a quantum world; it's impossible, but we can start to see traces of what does exist. Um, I'm going to talk a bit about the queer relation to queerness and quantum. We've got a few minutes left, um, so I've said that quantum physics is non-binary. Scientists wouldn't call it this, but it is. Quantum computing is non-binary. There's a few quotes from queer theory that have been instrumental in my practice. A woman called Freya Jarman wrote a book, Queer Voices, and in it she talks about how um, the concept of she doesn't link it to quantum, but she talks about how the concept of queer doesn't need to be linked to any specific category like identity, although it can be. But she talks about how queerness can be productively linked to any type of system. And she says that's because the concept of queerness is overspilling, it is unbounded. And that itself reminds me of a quantum particle. Quantum particles are unbounded. If you think about going down to the microscopic level, the atomic world, you might think particles become more and more precise, more and more point-like, like a head of a pin. But that's not the right way to think about it. As you get smaller and smaller, what happens is a point, and then these entities start to stretch out in space and time. So I often use slime in my practice. You'll see shortly there's a video called Slime Crawl as a metaphor for these quantum particles. Technically, this is called wave particle duality. But a particle, something like a snooker ball or a football that you might think is rigid and bounded, actually behaves like a wave. And this reminds me of Freya Jarman's idea of queerness, that the concept itself is overspilling and unbounded. Perhaps queerness is wave-like. Karen Barad, who is really instrumental in my practice, Karen Barad works at the University of Santa Cruz. They have written books such as Meeting the Universe Halfway, and they have a background in quantum physics, quantum field theory, and but they also apply this now to philosophy and feminist theory. And in their essay on touching, they write about how the quantum theory of touching is radically queer because the electron not only touches everything else in this superposition, but it also loops back and touches itself. So she says in the quantum theory of touching, you're really touching the other or the inhuman or the invisitation within yourself. I really like this quote. That's in her essay on touching. And finally, at queer theory from a gender perspective, Jose Esteban Munoz writes about how queerness is always out there on the horizon. This is in their book Cruising Utopia, where we're situated here in the straight time or in this heteronormative capitalist society, but queerness is always just out of reach on the horizon. And that, in a way, reminds me of how we're situated in the Newtonian world. We're situated in the world of seemingly boundaried objects, rigid forms, linear time. But using quantum computing, we can start to reach this queer horizon. We never can get there. Quantum physics is a little bit like Plato's cave, where we can start to see the shadows, we can start to see the traces of what is beyond this horizon, but we can never ever actually get into the quantum world because of quantum collapse, where if you observe a quantum system, you destroy it. But what we can do with quantum tools is start to approach this horizon, and that for me is really exciting. As you can see, the slime crawl is playing in my background. I use slime a lot in my practice because for me, it's a really excellent metaphor for not only quantum bodies, but thinking about our bodies as entities that are unbounded. We are human beings, are slimy creatures. All of our orifices are slimy. If you put the tongue on the inside of your cheek, you can start to feel our radical queerness, our sliminess. And this puts us in relation with all other life forms. Suzanne Vedlich, in her book, The Natural History of Slime, writes that there's no other no multicellular life forms that haven't got some sort of mucus or slime or viscous gel within them. It's a necessary component for life. So slime for me is an entangling medium. And it also relates to wave particle duality as I've mentioned. So to finally, before I finish, I just want to mention a work that you'll see come on the screen very shortly called Heartbreak and Magic. I made the work this year. It was commissioned by HTC Vive Arts, who make the VR headsets. And it looks at the quantum nature. Here you go, this is a video. It looks at the quantum nature of existence. Um, it's a deeply personal work. I lost my sister in 2019 very suddenly. And because I'm not religious, after she died, I really thought about quantum physics and what it could tell us about life and death. Could my sister still exist somewhere woven into the fabric of the universe? The equations of quantum physics really do predict the multiverse. But as Abdul said at the start, there's no theoretical test, or there's no while the theoretical knowledge is there, there's no experimental test to show that the multiverse exists. But there's lots of clues in the mathematics. For instance, it's impossible to delete or copy unknown quantum information. So, what happens to the information coded in our DNA at the atomic level after we die? Could it still exist out there? But could we still exist in unbounded forms somehow? So the work, what you're seeing here is a clip from the end of my VR work where time is running backwards, which can also happen in quantum physics. In quantum computing, actually, time runs forward and backwards. It's a reversible type of computation. And thinking about how grief is nonlinear as well, and how we can go back and sort of explore existence through the possibility of quantum physics. I have no answers. I can't say what happens to us after we die or what happened to my sister after we died, but I know when you know so much about the universe, when whether you understand quantum physics like I do, or if you're a cosmologist and you're looking up into space, we realize that our knowledge is so limited and there's a gap beyond that where belief systems can come in and take the place. So to summarize, I think artists and designers or creative practitioners of all colors and positions, we really need to think about quantum tools because they're being developed really quickly by big tech. But there's hardly any discussion in the public consciousness yet about quantum technologies. But when they're developed, they will undoubtedly change the world. So I invite people in the audience, anyone who watches this talk, to start thinking about quantum computing, quantum physics in your practice to help contribute to the debate about what this quantum future will hold for us, hopefully from a non-binary queer perspective. Okay, thank you.
Well, first of all, I would like to thank you so much, Dr. Libby, for your generosity, for the vulnerability that you also showed sharing the story at the end, and for introducing us to the world of quantum physics in such an accessible manner. I think it's such a difficult topic to unpack, and I can't wait to unpack it with you in the panel afterwards. So thank you very much. Thank you once again. So this talk has been really one piece in a two-piece collage. The other piece is actually concerning Miha Turšič. To introduce, I want to say that all bodies on Earth, human and non-human, are inextricably bonded to one celestial body, the Earth. If we take a perspective from outer space and look back at the Earth, in what way can we cultivate new ecological realities and Earth-space futures? Miha is an artist, designer, and researcher dedicated to developing arts and humanities in outer space. He designed works about the human condition in the outer space, developing post-gravitational art and artistic satellites, co-founded the Cultural Center of European Space Technologies, an institution with a dedicated cultural space program, and actively developing cooperations between space and art institutions across the globe. Currently, he works at VAG as the Open Space Lab lead and concept and project developer specialized in collaborative research and innovation. Thank you for being here.
Thank you for invitation.
All right.
Let's start with small experiment because there is reality so far and so hard to imagine. So there is a space where there's zero gravity. However, usually we understand zero gravity as like floating, but in fact it's a constant free fall. And there is a type of zero gravity of like 500 nanometers per square second. And this place of zero gravity is approximately, more than 100 astronomical units away from here. As one astronomical unit is a distance between Sun and Earth, so it's pretty far. And since I'm supposed to talk about bodies, so there is a body, actually it's two of them, and they travel with a speed of 15 kilometers per second. So try to imagine this reality and the body in this reality that travels with a speed that you would even not see. So if something passes you by with 15 kilometers per second, you would even not notice it. And it's so far also that it's going to travel for next 100,000 of years. And in its side, nothing will actually change. So being in this reality and being body in this reality, and actually we have two of these bodies quite close to our solar system. They're called Voyager 1 and Voyager 2. So these are two, I call them bodies, that were launched in mid-1977. So they're traveling almost for 50 years through the outer space. With my partner, Spela, she's here, more than 10 years ago, our question was, is there art outside of our solar system? Is there life outside of solar system? And our point of origin, the research focused on these two spacecrafts, two space probes, mainly on Voyager 1. At that time, I worked with the space, in the context of space research on the instrument that is attached on the Voyagers. It's called PLS. It's measuring the plasma of our solar system. And we try to kind of come up with the understanding, what is art out there? Can art be produced in outer space? So not something that you make on the Earth and then send to outer space like a message. No. Can we have an authentic, artistic, living process going on outside of solar system? And we came up with a proposal of a metabolic algorithm digesting data from this PLS instrument and producing a signal that doesn't exist in space outside from Earth. It's a signal of life. So there's no signal that we would catch or register with our existing technologies in existing space. And I will just give you a sample of this signal that we produced to be produced on the Voyager. It was never uploaded, but it was made for the Voyager to digest data captured and measured on the space probe. And then it would be transmitted through the space, also back to the Earth. By the way, the signal from the Voyagers travels to the Earth about 16 hours and at the speed of 15 kilometers per second. You can also imagine that it's hard to catch or understand where even this signal was sent from. So this is kind of was an experiment or an artistic experiment on the question, can we produce art in outer space? Can we produce life in outer space? And what's the most important here, when there will be no humanity and no Earth and no our solar system anymore. So it was experiment in the art and life in outer space. Moving on, we go to the date is the Valentine's of 1990. It's the time when the Voyager 1 just passed the, I think, the Pluto orbit. The Pluto's orbit is at around 41 astronomical units from the Sun, so it's way back. I mean, you see how far Voyagers traveled in these last 40 years. And at that time, on the Valentine's of 1990, the mission of the Voyager performed a quite special maneuver. It was end of scientific mission, and they used the Voyager to capture the portrait of all our planets in our solar system. It's called the family portrait. It's a long story, long anecdote, how this maneuver happened. What is important that what we got, what you see in the vertical image, is the most distant portrait of Earth. You can call it selfie. It's called the pale blue dot. What you see as a dot is not even a pixel large. It's just 0.12 of the pixel. So it's really the smallest portrait of Earth and the most distant portrait of Earth. However, in my current research, in the context what we call more than planet, we're trying to understand this more comparative understanding of planets, not just from astronomical, this dominant physical cosmology, but also all others. We see that these kind of realities that are produced through space technologies are, of course, very biased. It's called hard science, not including all the soft sciences, not including all the arts, which they call the non-professional thing, not including all the indigenous and situated knowledges. So all this understanding of planets in outer space is really biased and, I mean, more or less useless in the realm of today's society. On the question of bodies. So since the reality in what we commonly understand as the outer space is so inhuman. So when you go there, I mean, radiation is so vast that you would burn, just fall apart. So that's why bodies out there we call, in the outer space, we are rovers. In the outer space, we are space probes. In the outer space, we are satellites. You can never be a biological body in outer space. And though you could see all these technologies as a kind of a prosthesis, as a kind of a technologies that help us be out there, they're actually not something external to us, they're very internal. They're very internal to our economical and social systems because they completely depend on them and they also completely serve them. And what are we using? What are these technologies used for? I mean, the narrative of exploration, going out there, we are very much familiar with these narratives from early colonial practices. And it's ongoing. So these are all very neo-colonial practices of mapping the territories outside of our Earth, of our home planet. they're mapping this empty space in between, what use it could be. What you see here at the bottom is the map of moon, and the only thing they map on moon is the use of moon for the economy. So where are the resources? Where are the minerals? Where is the energy that you can harvest? Where are the places to put your settlements and to harvest solar energy? So the way of understanding moon and Mars is very, it's completely for the extraction of resources. The human bodies in outer space, like cosmonauts, astronauts, they are there just to maintain the infrastructure. They are there to do the labor of all the experiments that technologies could not perform. So they are the laborers in outer space. They are not there to perform their own personal agencies. They don't have their own identities out there. They go there with collective identities, with served identities. So all of these bodies that you see here are not external, the outside, the outer space bodies. They're very much internalized bodies, bodies of the technosphere and of the Anthropocene and the anthroposphere. So these are the bodies that produce this new understanding of our planet. So our research within the Modern Planet is based on understanding that more than 90% of our planet, Earth, is under human influence, footprint, impact. So when the whole planet is managed and governed, you see that there's no much nature anymore, no culture, all these concepts are falling apart. So we need new understandings here. And we see that the whole planet actually is very internalized, very controlled. There's not much mistake anymore on this planet that would kind of escape this internality. The SpaceX satellites, it's more of thousands of them in the Earth orbit, are actually controlling. They provide services to military, Ukraine and things like that. Of course, in very controlled way, very biased way. So through the last 2-3 years, we studied all these different concepts, all the knowledge cultures, all technologies that help us understand the territories that separate this internality from the externality. So where can we actually find at the end bodies that escape controlled environment, controlled knowledges that exist today? Part of them are what we call in the context of the planetarity, the terrestriality of modern human, of critical zones, of the contaminations and xenopositions, because they're messy, they're hard to understand, they're impossible to understand. You cannot control them anymore. So a few examples of these kind of externalized bodies in outer space. I will start with, I'm from Eastern Europe, from Slovenia, and cosmism and suprematist art are important for me. And my main reference in this context is a text from Kazimir Malevich in 1920, when he wrote a small text. But in the text, there was important reference, description of objects being in the orbit and living their own lives. And it kind of resonated with me. I mean, what is he talking about? Having your own life outside of this planet, what does it mean? Of course, he referred to the non-referential art, where artwork lives its own life. But then putting this kind of concept outside of the planet, you see that, okay, probably there's a different form of life out there. And when you look today at some of the examples where life escapes control, you have bacteria that lives in the most sterile environments, in the clean rooms where the satellites are assembled, because this is the perfect ecological niche. There's no competition so they can enjoy. It's perfect. It's paradise for them. You have bacteria that lives on the surface of on the outside of the space station. And they're observing them and testing, and I mean, they're fine at the highest possible radiation for years. There was an accident, the crash landing on Moon, and on the lander, there were tardigrades. So there's a high chance, since the lander crashed, that these very small water bugs now live on Mars because they are resistant to radiation. So, sorry, it's Moon. So Moon is claimed as abiotic, without life. Now there is population of water bugs on the Moon. So it's kind of getting contaminated, it's getting alive, not in intentional way. So this is how life is escaping, how life is escaping all the control, all the sterility, all the modernity, all the hard science. Important part of this contamination is also inside of the space station, because astronauts and cosmonauts, they breathe, they sweat. So there's a lot of microorganisms in the air. So they constantly have to clean the space station, sterilize it from life prospering in this very controlled environment. And my beloved project, we call it Roscosmo. We work with international artists, researchers, scientists, with the organism that is called the Roscophensis. It's a flatworm that when they're young, they ingest algae, and the food for them is produced inside of their bodies. So they're kind of independent, more or less, from the environment. However, the worm has to sunbathe itself, so the algae inside, to the sun, so that the algae gets, the sun energy, and then the algae produces food for the worm. However, they live in Brittany, in the coastal area where tides are like 10 meters high. And they're hiding in the sand and then coming out in very gravitational way, because the Moon is causing all these tides. So we have an organism that lives, so we have an animal that depends on the sun because it's a photoreactive, and it depends on the Moon. So the reality of this worm doesn't see, there's no difference between sun, Moon, and Earth, because this worm lives with all three of them. There's no internal or outside for this worm. So our goal is to send this worm to the space station and to the Moon to see how they react when they are on the Moon, and how they influenced from the Earth back. I could go on, but I have to finish, and I will finish with the main project I'm part of. It's a 50-year-long project that started in '95, very shortly. It's an abstract theater. We're trying to get rid of everything terrestrial in theater. So the stage, actors, also the audience, sorry. And we're trying to substitute actors with the so-called umbots. It's a very Eastern concept of what on the West you're familiar as an artificial intelligence. So robot, umbot, it's not a worker, but it's a thinker. So these substitutes are going to become satellites. We will put them in the orbit. So the substitutes of the actors will kind of be placed in the orbit and produce art from the orbit and transmit their play through transmission through the radio to the ground. From '95 on, we managed to produce a theater in zero gravity. We are building cultural infrastructure to produce and to understand art, culture, and humanities in outer space. So we're working on different kind of experiments, collaborations. It's a kind of intense life of doing something that is so impossible as art in outer space. And everything relates to not fixed understanding of bodies. So all the assumptions from 95, how bodies appear in theater or in general, is literally falling apart, and we're trying to relearn through the process, through the practice of working on with these technologies and arts in outer space context to relearn how bodies are shaping in a critical way, of course. Thank you.
Hello. Yeah. Thank you so much again for adding fuel to our fire of I think, cosmic curiosity. I'm just going to put the questions aside. We have just a few minutes. And I think, I don't know if Libby's with us as well. But I mainly have two questions. First of all, how did we get here? In terms of how did you, I think in both your cases, you had a concept, a hard science, like quantum physics, or let's say some sort of like gravity or cosmology, and you said, hey, we need to use this to tell better stories. We need to queer the phenomena a little bit. So what was the thinking process? How did you end up in this space with these kind of experiments? That is my main question for now. So yeah, you can start. Yeah, Dr. Libby, you can start.
Okay, I can start, sure. How did I end up in this space? That's the main question. Sorry. I was texting with one of your sound engineers. So, yeah, so basically, I mean, quantum physics for me is really magical because it's so beyond our everyday experience. And as a scientist, you know, you start off with that magic, but then for me, at least, you kind of lose that. So art enables me to kind of get that back. But I really think that, like, I'm really interested in critical discussions around quantum tools, how we can sort of, not to instrumentalize art, but how art can help us reimagine different futures or the present as well, and to move beyond kind of some of these limiting, prejudicial systems that we find ourselves in. How can quantum physics help us hope that there's something more to this reality than we experience or that we're wrapped up in at the moment?
Yeah.
Yeah, in my case, it's a series of mistakes and failures. And I mean, it started with, my background is in product design.
Oh, wow.
And like, you know, you want to make your own signature chair. And then I wanted to make a chair for zero gravity. I mean, that would be a signature chair.
Yeah, yeah.
You don't need a chair in zero gravity.
But this is a typical design problem, right?
No,
chair.
I mean, what I learned from this experience that I even don't understand what the problem is. No, I mean, solutions, forget about them.
Yeah.
Understanding problems is producing all these questions. And for me, art was then an area that gave me a freedom to research to all these questions. And I was constantly failing in answering or getting any kind of answer on all these questions. But it was constant production of new questions. And what is specific in doing art in outer space, first, you cannot do it alone.
Yeah.
Second, you need institutions, you need organizations, you need infrastructures. We don't have institution for art in outer space, neither culture, neither studies. So that's why we made our own. Of course, you fail because this is very political. Hard science rejects all the arts, so it's really hard, it's impossible, and yeah, I failed, we failed. So it's a constant series of failures. However, doing art it's a degree of freedom for at least asking, for at least trying. And also the story of the worm. I mean, were twice already talking with space agencies. Okay, can we do it? How can we do it? Okay, you can do it. Okay, let's go into the process. And then it stopped for different reasons, of course, because art has no priority. This artistic research has no priority in outer space. So it's a constant, it's a series of failures, but at the same time, it's also a story how we research outer space. Again, not through arts, not through philosophy, not as intentional culture. Yeah. However, this culture is produced by these kind of practices, which are quite biased, colonial.
I'm not going to lie, I think I gathered from both your talks an element of frustration that I now share with you both, because let's say in the case of quantum computing, there was an opportunity there to start imagining queer futures, but we see it only being used to solve linear problems of deepening modes of extraction, with us kind of trying to look for, like, outside of the Earth, we mainly use our observations to look inwards again. So we have all these opportunities to tell different stories, but we see that the mode of inquiry now, the dominant one, is again feeding back into our anthropocentric views of the world. Maybe to end this, because we don't have so much time, if I can get from each of you an invitation that the audience can leave with. So what is one paradigm shift or a quick paradigm shift that people can walk out with? So I don't want to walk out with this frustration or sit with this discomfort for too long, because I love convenience. So what would you tell the audience? So Dr. Libby, maybe you can start.
Okay. This is hard on the spot, but yeah, I guess what I said at the end of my talk, how because in the arts and in culture in general, we're used to storytelling and reimagining. So how can we somehow, it's this question of like the dominance of big tech, isn't it? And how they have much more power over us than we would like. So how can we find like the wild liminal spots in these technologies and use them for like reimagining in this sort of queer, non-binary way? So obviously we don't have control over these tools, but there are these like glimmers or pockets of possibility. So how can we like find those and then wormhole into them and create new futures together?
Awesome. Finding liminal glimmers. I love that. Thank you.
I mean, my experience is question everything that seems for granted. Also, we are all in space. You don't travel to space. Nothing of what we know is outside of space. Yeah. So just don't accept concepts like outer space and Earth and there's something outside and we are here stuck and we should have an effort to go there. We are out there. Yeah. We are the outer space. So come up with your own questions. Question everything. Not necessarily in critical way, but just question. That's it. Yeah.
It's almost if we borrow from colonial theory, we're othering outer space, and it's a colonial notion at the end of the day to be like, it's something that I need to go and explore. Well, you're embodied. You're part of it.
You are the outer space. That's it.
Well, perfect. Thank you both so much. A big round of applause for our wonderful speakers. Thank you for joining us, Dr. Libby. Thank you for being here. And I think we have one last session in 15 minutes. Thank you all very much.